algebra students, this is our introduction video for our lesson on solving systems by elimination. So the first part, what is elimination? For example, if I asked you to solve this system, right now we know two ways. We know solving by graphing, but if I wanted to solve this by graphing, I would have to change both of those equations into slope-intercept form and then find graph paper because there's no graph here. That would take me a while. If I wanted to solve this by substitution, we said for substitution you need x equals or y equals. Here I don't have that, so to solve by substitution I would have to move stuff around and have x equals or y equals. That takes a while. This system, though, is perfect for our third method, which we call elimination. Elimination means combining your two equations so that one of the variables eliminates. For example, these two equations, I can combine those equations. I can add those equations together, and it helps me. And you'll see why it helps me when we do it. If you add your two equations together, 2x plus 4x gives me 6x. 3y minus 3y eliminates. And so my equation no longer has y in it. To finish, I can say 6 plus 12 is 18, and I have this new equation that only has one variable in it. So I could finish solving it, divide both sides by 6, and have part of my answer that the x-coordinate is 3. So elimination looks like this. We're going to be combining our equations so that the x or the y eliminates. It cancels out. Now we know from past lessons this right here is not my final answer. We know that our answers always look like a point with an x and a y. So right now all I know is my x-coordinate, but we can do the same thing we did in our previous lessons to find y. What do you think we're going to do? Well, I know x is 3, so I can substitute that into either equation and then solve for y. For example, I'm going to use my first equation, 2x plus 3y equals 6. And then if I want to substitute x for 3, it would say 2 times 3 plus 3y equals 6. And then solve this equation. Go ahead, pause the video, and practice solving this equation to finish finding our answer. When you finish solving that equation, you get 6 plus 3y equals 6. I subtracted 6 on both sides to cancel my constant, and I got 3y equals 0. Divide both sides by 3, and we get y equals 0. And so there is the rest of my solution. This process right here, it's the same thing you did when we were solving by substitution. The new part is just this part here in orange where we're using elimination to eliminate one of your variables. I've got one other example here of what you might see when you're solving by elimination. Before we look at that example, I really want to emphasize the elimination part of this. The part that eliminated in this system was our y, and it eliminated because we had one y with a positive 3 in front and another y with a negative 3 in front. If you want something to eliminate, you need those signs to be different and the number in front, the coefficient, to be the same. That does not always happen though. So for example, this system right here, I've got 5x minus y equals 8 and 2x plus 3y equals 10. If I tried solving this the same way we solved the one above and I tried adding the equations, 5x plus 2x is 7x, negative y plus 3y is 2y, nothing eliminated. So that does not mean you can't use elimination, it just means you need to do something first. If I want to use elimination, we said I need the numbers in front of my variables to be the same, just different signs. And so we can use what we know about equivalent equations to make that happen. We learned one thing you can do to make an equivalent equation is to take an equation and multiply it. So for example, I could take this first equation and multiply it by a number to help me eliminate something. Now what number could I use? Well, I'm looking at those y's right there. If I wanted y to cancel, right now I've got a positive 3, I would need a negative 3 in front of that. And so I could multiply this entire equation by 3 to make an equivalent equation. That would give me 15x minus 3y equals 24. That helps me out because the second equation doesn't need a change. It can still be 2x plus 3y equals 10. But now when I look at those equations, I have something that will eliminate my y's again. After this, it's going to look the same as what we did above. So go ahead, get some practice, pause this video, promise me you'll pause it, and try finishing solving this system of equations now, and then come back to see how you did. So this part right here in green is what the first part of solving should look like. After you combine your equations, I'm doing that now because my y's will eliminate. You get 17x equals 34, and when you divide, you get x equals 2. So right now I have half of my answer. I know that the x coordinate is 2. If you didn't finish this earlier, go ahead, pause again, and finish solving the system by finding your y. So this part over here in purple is the second step. I've got x equals 2, so I substituted that into my first equation, and it looks like this. When you're solving, be really careful with that negative y right there. I need to keep that negative sign, and then divide by -1 to finish solving, and -2 divided by -1 gives me a +2. Now remember, you can use any equation you want for the second part. So I used that first equation. You could have also used 2x plus 3y equals 10. The solving would obviously look different because it's a different equation, but it would give you the same exact solution. I would subtract 4 on both sides. I get 3y equals 6, and then divide both sides by 3 to get y equals 2, the same answer. We will be doing more examples like this with elimination in today's lesson. Thank you so much for watching. Bye, y'all.